Nuclear reactor. A nuclear reactor is a device or a furnace where controlled fission chain reaction is carried out and the energy released is used to generate electricity. Here you have an external view of a pressurized water reactor or PWR. Click on the containment chamber to view the parts of the nuclear reactor core. The reactor core, where the nuclear reactions take place, there are the fuel rods, the control rods, the moderator, and the coolant. Outside the core there is a turbine, a heat exchanger, and a part of the cooling system. Click on the labels to know their function. Fuel rods. This is how the fuel rods are arranged in a reactor core. Inside each fuel rod, there are hundreds of pellets of enriched uranium fuel stacked end to end. A neutron is used to trigger the reaction. A suitable neutron source is placed in the neighborhood of the fuel rods. The neutron source is not shown here. Control rods. Inside the core there are control rods to capture neutrons. An example of such a material is cadmium. These control rods are connected to machines that can raise or lower them into the core. Coolant. A coolant is used to absorb heat from the reactor core. Most of the nuclear power plants use water as coolant. In many of the reactors, the coolant and the moderator are one and the same. Moderator. The moderator is used to slow down the high-speed neutrons. If a neutron is moving too fast, it will pass right through the U-235 nucleus. It must be slowed down to be captured by the nucleus and to induce fission reaction. The most commonly used moderator is water. Protective shielding. The reactor core is given a thick protective concrete shield so that there is no leakage of radiation. Generation of electricity. When the neutrons strike U-235 rods, it splits into barium, krypton, and neutrons. The position of the control rods are adjusted in such a way that only one neutron is left behind to continue the chain reaction. At this stage, the reactor attains criticality. The coolant is heated by the energy released during nuclear fission reactions taking place inside the core. However, this hot water does not boil because it is kept at an extremely intense pressure. This high pressure raises its boiling point above the normal 100 degrees Celsius. The hot water, being lighter, rises up and enters the heat exchanger through a series of pipes. The water, which is the moderator and the coolant, is radioactive and hence it cannot leave the containment chamber. Its heat is transferred to non-radioactive water in the heat exchanger. The metallic pipes conduct heat from the moderator to the normal water and convert normal water into steam. This steam moves the turbine. The turbine in turn moves the coil of the generator to produce electricity. What happens to the coolant and water? The coolant, which is now at a lower temperature, is then pumped back into the reactor core. The steam, which is also at a lower pressure, is cooled in a condenser and circulated back to the heat exchanger. Many nuclear power plants use steam towers to cool this water with air. These are generally the buildings that people associate with nuclear power plants. In the reactors that do not have towers, this water is purified and pumped into the nearest body of water, and cool water is pumped in to replace it. Other types of reactors are the heavy water reactor (HWR) and boiling water reactor (BWR). A heavy water reactor uses heavy water as a moderator instead of normal water. Heavy water can also be used as a coolant.